The stage is all yours. Thank you.
Thank you. You heard about machine learning operation many times today, and you'll hear a bit more. So bear with me, there are 2 more presentations, and you'll be home. Not many people actually put this slide about themselves, but I really want to say about a few words about myself. I'm the MLOps lead at HOLCIM. We have a global team made of data engineers, data scientists, ML engineers, business analysts. We work with vendors across the globe. And we also work with freelancers. So it's quite interesting, quite global, and exciting. When I'm not working for HOLCIM, I have other interests. I'm a data-driven parent, which means you will see actually what it means if you can just browse and check my blog, where I'm marrying the passion about raising kids and data science in a blog called The Baby Data Scientist. When I'm not doing this, I'm trying to maybe give something back to the community. And I'm mentoring junior data scientists, data analysts, people that are interested about MLOps. It's quite exciting and rewarding and tough work, but I love it a lot. And recently, I'm experimenting with something called Etsy. So I just launched a store about this type of things like data and design and funny T-shirts and things like that.
Cristina, I'm sorry to do this so publicly, but I actually knew about your store and I made an order and I have some feedback, right? So actually the materials, great, the design, great, but I don't think this will fit me, right? So I think there's an error somewhere in the supply chain. Maybe you could use ML to sort that out because not a good fit, obviously.
Yeah, sorry, I've been experimenting with AI and you see LLMs are not that stable in production yet, so sorry about that. Reference, are just free. Go ahead. Okay, let's see what's next. Too much about me. Let's see if the clicker actually works. No? Help.
She is using the right clicker, guys.
Yes, the right button. Another glitch in the system, so more about me then.
Oh no, it's working. Let's see if we can get that sorted. If not, I will offer my services as clicker once again for today.
It worked during the break, so I think it should work. Anyways, it was next slide that was about agenda. I don't want to lose too much time. So I'll just say that I want to explain what MLOps is, but from an end-to-end perspective. I want you to have the feeling about like what HOLCIM does, so to get this whole understanding about the business, our pain points, how we work, what type of processes we have, what type of people we work with, what is a product team maybe, and I just picked like one use case to describe about our architecture and the challenges that we faced. And at the end, hopefully, you can help us with one of the challenges. I'm not saying much, but try to be interactive, I don't know, somehow. Good. So that was basically the agenda. So HOLCIM, this is our mission. So it's building progress for people and the planet. But I think that you're very interested in the main product, yeah, cement. I'm pretty sure you are. How cement is actually produced. You see that cement goes through a series of processes. It's first, basically, you have to go to the quarry to query the limestone. Though this is the input. The input goes through grinding processes, through like big machineries that will transform these big rocks into a fine powder. Then it's being combined with other additives, it's being burnt. And I mean, the burner is something crazy. It's called the kiln, and the temperature goes to more than 1,000 degrees. So it's kind of hot in there. And after it's being burnt, it's being transformed into and stored in silos. The quality of cement is being let's say, measured, and some intermediate output that is called clinker. Basically, this is the most expensive part of cement, is controlled, so we are sustainable for the future as well, because this clinker, will be translated into a lot of emissions. But bottom line is that this is the crazy part of how cement is produced. It's a lot of processes. And what Industry 4.0 will actually mean for cement and manufacturers will mean that hopefully with the use of IoT, smart sensors, drones, ML, AI, we are able to digitalize and to make the process more efficient, but also to be, let's say, to manage basically the lives of the people that work in these processes, because they are dangerous. And if something goes wrong, then somebody can get hurt or, unfortunately, can also die. So it's crucial that these machineries operate in the right levels. They are being maintained. People that are working in manufacturing are very good engineers, very technical people, and very, they respect health and safety very well. I just want to give you the context. So this is the type of process that we follow. But why ML for manufacturing, and why not something else? I can tell you that ML is not the only solution, for sure. Like there are like tons of specialized people that are working to make this happen and to make HOLCIM great, because you probably heard of HOLCIM. Is one of the builders, the biggest player in the manufacturing, especially in producing cement. Well, there are some use cases where ML can help, not totally, not in all the locations, but where it can help, it's actually very good. So we tried it for predictive maintenance, we tried it for quality control, and we have different products driven by people in the business, by product owners that basically don't start something with ML unless it has value, unless it's proven in a business case, then it's worth it to actually have it in production in multiple locations across the world. How MLOps can help? Because ML, in general, like you have some machine learning that is predicting something, but MLOps is important because you'll have to automate it end-to-end, because you cannot afford to, hire an army of data scientists, ML engineers, to actually keep all these models accurate in production, reliable, efficient. You just need a process. You need tools as well. You need to keep it simple, because if you go complicated, then the cost goes up, and it's very difficult to maintain it. MLOps, it's about having automation, about testing for data, testing models, testing systems, about monitoring end-to-end, like how reliable the whole process it is, how reliable ML is, of course, monitoring for data drift, and so on. And it has to be reproducible. So if you run the same process twice for the same data, you have to produce the same result. You cannot have a random result within. Okay, and now what type of challenges ML face in manufacturing? And actually, I had this backed up by Andrew NG. You probably know about him. He's speaking about two major challenges, and I truly empathize with this. We don't have enough training data. And why not? Because we rely on this type of devices, like sensors, like drones, to actually produce the data. So if those type of devices are not installed, then you don't have historical data. And yes, you can build something with synthetic data, but I'm not sure that manufacturing is ready to just have something. It has to be accurate, and it has to be proven that it works. Otherwise, it's dangerous to be put in production where like engineers will rely basically on your predictions. Another problem, a very known problem, is that is the long tail problem. I saw it in another presentation today in a different context, but basically what does it say? It says that the value that is being generated from these different use cases in manufacturing are produced by ML, there are small values, like individual values. Of course, if you put them together, maybe they will mean like something like a big thing. But because they represent a small relative amount of money, you will basically need a system or maybe a process like MLOps to manage them in a cost-effective manner. Because as I was telling you, in order to tackle small custom problems, you will need like an army of data scientists. Nobody can really afford an army of data scientists, or maybe they are not even enough on the market, but that's a different problem. So we are tackling this problem, the long tail problem, by having automated process in place and trying to generalize for custom problems, trying to find as possible a general solution that can apply to multiple problems, small problems. HOLCIM invests a lot in digitalizations. They have programs, and of course this translates into deadlines for us. MLOps sits under a lot of pressure. We have to deliver a number of, let's say, solutions in on a quarterly matter. We have product owners that care individually for their own products. We have product teams that work hard to achieve their goals. And this is translated into results as well. So until now, there are 800 applications deployed in more than 50 countries. And there are more than 1,500 employees that are using actually the solutions. And this is one of the big and the most, let's say, challenging use case that we are working on. You probably heard even today about predictive maintenance. It's not an easy problem to tackle. We deployed until now 106 solutions, but these translate into more than, I'm saying here, 900 models in production. Models that are ML or domain models. Because predictive maintenance is something scary. Like the initial request from our product owners was to predict failures. But how can you predict failures if they are just like a handful of failures, like across the world, not to just rely to one equipment? So it's not necessarily an ML problem, but if you divide it into tiny pieces, it can be translated into ML. For example, we don't want to predict failures, but we want to know when anomalies happen. When anomalies happen in a specific equipment. But what's even challenging in manufacturing is that if you identify correctly the anomalies and then you send them to the operators, all the anomalies that you identified, then they will just not like your product because they receive a lot of alerts as a normal standard practice in a factory. They receive a lot of alerts. So they just want like the strong alerts that will say that an equipment is going to fail. So that's why it's a very difficult problem, and that's why we are working with different type of vendors, with platforms. We have an internal team that is trying different things, different algorithms. We also have very strong domain people with us. We call them SMEs, but they're like business analysts. So they know everything that happens in a plant, and they can help us identify the right tools to actually catch the right anomalies. In terms of architecture, I just put there the most, let's say, challenging thing for us. We cannot create something and deploy something only to the cloud. We have a hybrid environment of edge and cloud. And the requirement came from the plants, so from the cement plants, because they care about the moments when, let's say, the network issue, they have network issues. So if we will, let's say, predict in the cloud, they will not have, they cannot consume those predictions. So one of the use cases was to maybe for us to train the data in the cloud, to monitor everything in the cloud, but then to predict at the edge. It's because of the internet security, it's because of connectivity, security, but cost. You probably heard that cloud is not cheap, and if you want to do something at scale, then this is getting more complicated. So in order to make predictions in manufacturing, you have to partner with a lot of stakeholders. You have to partner with the infrastructure people, with operations people, with business. You have to make sure that plants are well equipped, so to be able to install the sensors and then for us to extract the data. Now, I try to map out a bit one of the use cases that we have related to wired sensors. So how does it work? So basically, once a budget is approved in a plant, the plant representative goes and installs wired sensors on highly critical equipments. So equipments like motors, like gearboxes, that are critical for the whole operations. They install these sensors. This goes through a process control system in the plant, and the plant collects the data at the plant level. This data is being sent to globally. So we have data available for all the plants, but then it's also available on an edge machine in the plant. Because we have daily data in the plant, we can deploy our ML models and our data pipelines on the edge machines, where the plant representatives can consume directly these predictions, but we also export everything, like all the results, to the cloud, so we can monitor, we can update the models, we have control of what's happening. We also export logging to make sure that whatever we build is reliable, good quality, it's running, and so on. For this specific use case, we use Google as a cloud provider, and we store data in BigQuery. But as I told you, like HOLCIM uses multi-cloud. We have different type of providers for cloud. We try to be cloud agnostic in applications as well, as much as possible, and not to get vendor logged in. What else? We also have an UI, so a dashboard basically, where the plant representatives or the managers, the maintenance representatives can go and investigate further why an anomaly happened, but they will get prescriptive messages in the alerts when they receive. So basically, if something goes wrong, they will get notified, and they will get notified in time to basically plan a maintenance. In a factory, a failure builds over some months. So these big machines, they don't fail from 1 minute to another. So it takes months to actually build up a very big failure. So they need at least like 3 to 4 months in advance to know if something is going to happen. And they need to know, as I told you, because people can get hurt, because production can, get stopped, and this causes like millions of euros in losses. So we try to balance giving them the right prediction, the right alerts, but not giving too many of them, because false positives will just translate into a, let's say, plant not relying on the systems and not getting the adoption that we need in our tools. So it's complicated. How MLOps is optimizing, this scaling of ML models. So, as I told you, our team manages the 3 phases. So we go through ideation, where basically the data scientists are working together with the data engineers, with the product owner, with the SMEs, to create something meaningful, to collect the business objectives, but also translate them into success criteria for ML. So we want to make sure that from the beginning, when you produce a plan, everything is being measured. And we know if the experiment actually failed or can be moved to the next phase. So from a POC phase to a minimum viable product to MVP phase. We have streamlined steps. We work in Jira. Everything is controlled. we are kind of agile. I mean, most of the times. And we follow these 3 phases. So we have the ideation phase, which is more data science driven. Then we have deployment and operations. In data science, we follow this standard CRISP DM type of framework, where we go through business understanding, data preparation. This is standard, all the data scientists know, modeling, evaluation, and deployments. We want to document as much as possible in Jira, so we keep track of what worked well and what did not work well in terms of experimenting and so on. To be honest with you, some things work in a POC phase, but then when you move to production, actually, let's say that you realize that this is an iterative process and you have to go back to phase 1 because something was not aligned and something was not thought in advance. And I'll give you an example. We want to implement a model to detect anomaly detection, and we apply autoencoders, and everything is fine and so accurate, and business is happy, and we get like good results. But then when you move to production, and one sensor doesn't work, and that sensor was important to reconstruct the error, surprise, you realize that that's not good for production. So now I'm zooming into MLOps. So you saw how data scientists work. They use that framework to ideate and create something meaningful. But then I told you that we work in a product team. So we are product driven. We have a business stakeholder, a product owner that comes to us with a problem, so not with a solution, so with a problem. We work together with process engineers, these SMEs that I told you, process engineers or like chemical engineers, or it depends on the experience that is needed in that process to actually scope out what are the pain points and what data we need and what infrastructure needs to be in place for us to be able to deliver. And then we also map out what is the ML problem, if there is any, if ML can be applied into that process. We do the same things for all the new projects that we have, and then we move into data collection, into ingesting the data, preparing the data. We go through these steps, and everybody is aligned. We have dedicated people to work on the processes. We have, let's say, data engineers that are working on building the data pipelines. We then have ML engineers that are working on automating whatever the data scientists build and building the ML pipelines. We work together with a software engineering team composed of IT automation, DevOps engineers, software developers. So when our work is finished, we basically rely on them to help us with deployments. We're building like the CI/CD pipeline. Everything works like in a factory. We try to replicate the processes that we see that are successful in a factory in our organization as well. As MLOps relies on monitoring and maintenance, after a solution is in production and somebody in the plant is using the solution, we start the operation phase, where we have an assigned ML engineer that is looking after a bunch of the products in general from different locations to make sure they are up and running, to make sure that data did not drift, that the model predicts with a certain level of accuracy, if this is a supervised problem. To also collect feedback from the plants for our alerting system. And this ML engineer will work closely with somebody in the business or with a subject matter expert to investigate certain scenarios called failure modes, and to basically maybe book a meeting with somebody in the plant if they see something highly unusual that has to be investigated on top of the alerting system that we have. So we are also nurturing our products. We are trying to make our products better. And we are leveraging this operations phase to basically create new features for the product. And this works only because we are very strongly connected to the business, and they are using our tools and are giving us feedback. So we have this feedback loop where we check constantly if our business needs are met. I think I spoke a lot about challenges. And I try to list here a bunch of challenges that are stressing us out all the time, and we are trying constantly to find solutions. Some solutions don't even exist on the market yet, so we have to be creative. And why ML is so difficult in manufacturing is because even if you install the same sensor on the same equipment, the same model, in the same year, those equipments operate in different conditions because of the humans that are operating them, because, for example, something is in Egypt where it has an ambiental temperature of, a crazy temperature compared to in the Nordics where, the same machinery might not be stressed by ambiental temperature. So this is why our problems are custom. So even if we speak about the same machineries, they are not producing the same type of data, the same type of trends, and so on. Also, we still have to invest a bit of, let's say, data management in terms of how we standardize the name of the sensors, the tagging names of the sensors, because even if they might represent the same sensor, if it's located in a different, different part of the equipment, it might mean something else. So data quality is also an issue. I told you from the beginning that data quantity is an issue, but sometimes data quality is also an issue, one of the challenges, let's say. Also, I listed here the lack of initial information. So yes, we have a strong, let's say, collaboration with plant, but then initially you have to collect a lot of information from the plant to be able to build something meaningful. So somebody has to go basically inside the machine and to measure how thick is the ball, how, I don't know, all sorts of crazy measures. So basically you need to stop production. To stop production, it will mean that it kind of costs money. So this initial starting phase, it's challenging. It's not on us, on MLOps, but it's impacting, let's say, our targets of deployments in some locations. And lastly, this hybrid edge and cloud environments are kind of slowing us down and creating some hiccups in the process, because if you do everything in the cloud, it's kind of easier. It's more expensive, but it's easier. The edge thing gives us complexity, especially that the machines that we have are not that, let's say, performant. They have to be orchestrated and so on. And to end up, there are opportunities, of course. If you have challenges, there are opportunities, which means that we have a big backlog. We are busy. That's why we work with vendors. We work with freelancers. We have a small team internally that is also driving everything. But we have a lot of things to work on. I told you about the unified configuration framework that we want to build. There are things also in terms of technology, for example, smart sensors and high-frequency sensors that can be installed. So there are so many things that can be we can experiment with. Also, about tackling the problems with data quality and data quantity, we might try some crazy things like generating maybe synthetic data just to start a prediction, and then maybe within the MLOps processes to calibrate and to fine-tune and to correct by updating the model later on in the process. And thank you for bearing with me. Everybody's very quiet, so. Now, I hope that you enjoyed the cement speech. I want to finish by giving you a small challenge for the Big Data Week. the challenge is about challenges. So you heard how many, let's say, struggles we have. And I'm inviting you just to pick one and to maybe help us a bit by giving us a solution or by telling us how you would address it. Of course, we have prizes because you know about the Edge store. So we have 2 T-shirts. So
Actually, I could volunteer mine as well.
no, not the
So-
small one. Not the small one. Yeah.
Okay, guys, so you heard her. You're getting T-shirts. All you have to do is help her solve a challenge. First of all, thank you so much, Cristina. Your presentation was, as we say in Romanian, beton. I think it's appropriate, given the subject. Okay, guys, so let's see those hands up. You don't even have to ask questions. You just have to come up with solutions. I'm sure all of you do that on a daily basis for your businesses. You just have to adapt your skills to the current presentation. Let's see. They're great T-shirts. Proper sizes. I saw the other 2 that she's prepared. Anyone? Yes.
Yay.
Perfect.
Hello. I wanted to ask you about the edge. What do you use as management for the edge, let's say? I mean, you use from a cloud provider solution, or you use OpenStack or something like this?
I don't know if I know how to reply to that question, but we basically have a piece of hardware equipment that is not that, let's say, so it doesn't have a lot of resources. And how we connect, we basically use them as virtual machines and we deploy there. I think we have something like Linux on them. So.
No, my idea was to, let's say, to install from the cloud provider a solution that will make this hardware on the edge available on the cloud interface, and it will be easier for you to manage, let's say, as a single solution. But the problem may be with the internet connection if it's not very good. But this is my idea, let's say.
So you are solving the, let's say, the budget issue, but the other problem of internet connectivity is not solved, because if the plant won't have network, will have network issues, then they cannot.
Yes, I guess yes, the network part can be solved. I mean, in these days, I guess network bandwidth. I know that in plants it's a problem, but I guess it's not, let's say, unsolvable if.
Yeah, it's because of the remote locations where the plants are. And funny enough, the biggest problems are in Europe. Nobody would believe that, but.
Yes. Okay. So this was my small idea.
Thank you. Cristina, I have a small suggestion. Maybe you could skip to the previous slide a bit, so the audience can see the challenges. Maybe that'll give them more ideas on how to solve them. Anyone? Come on. I bet you right now that if you were to describe yourselves, you would say you're problem solvers. Here we go. We have someone who's an actual problem solver there. Can we get a microphone? Way there. Yeah, thank you.
I have more than 2 T-shirts, guys.
Hello, thank you for the presentation. I was wondering regarding the part where you install the sensors on the equipment. It came as a bit of a surprise to me, because with all of the Industry 4.0 hype, don't the equipment vendors support sensors directly? I mean, do you need to install custom stuff? And have you tried working with them to provide, let's say, more reliable sensors and stuff like that? Yeah,
so basically you have to think about this. Like every plant, basically it's a company, even if like it belongs to a HOLCIM group. So every company, every plant can come up with their own solution, because they have budgets. They have their own budgets that they have to decide. Also, we don't want to get vendor locked in. So we don't want just to, if somebody has, I don't want to say any vendors here, but if somebody has an equipment from a brand and comes with the sensors, maybe somebody in another plant doesn't have the same equipment, so it can't be standardized, basically.
Okay, I was thinking maybe an economy of scale. I mean, imagine you have like a limited panel of providers and you could negotiate with them. Anyway, thank you.
Thank you.
Thank you. We still have some time left. Okay, how about I ask you a question, maybe see if someone thinks of something in that time. So you were saying that you try not to send out a lot of notification because there are some false positives. How do you make sure you don't turn those notifications into basically a raw alert, which we all started ignoring? And what's the false positives rates at this point?
Yeah, they're not standard because, you know, we have products. Basically, one solution is being deployed for one equipment. So in one plant, you might have like, I don't know, 10, 20 ML solutions. So they're not standard. And we try different experiments in different parts as well. So how we basically we try to optimize on sensitivity of the model, so not on the accuracy. And it's tough, I will tell you. It's tough, and I'll tell you why alerts are so unpopular in plants. So there is a control room where they have like a bunch of monitors, and they receive a bunch of alerts about the systems. So these guys are trained, the engineers, to basically scan to see what's important and what's not important. So even if our model will detect that there is an anomaly in the equipment, that anomaly might be because somebody pressed too much on the motor, they put too much, you know, for the production, or maybe because it was a hot day. I don't know if that is so sensitive to the temperature. So our subject matter experts know all this type of scenarios, so they build these scenarios inside of the equipment, so we calibrate based on this knowledge.
Thank you. I actually had a follow-up question, but you kind of answered it beforehand.
Okay.
I was wanting to ask why not implement some automations that maybe turn off machinery when sensors feel like someone could be in danger. But given that there are so many factors and there's the human component, which we all know we're unpredictable, like someone could raise their hand right now, come up with a solution, that kind of unpredictable, it would make sense not to automate the process. But are you looking into that in any sort of way? Is it something that you're considering for the future?
Yes, so we discussed a bit more about the predictive maintenance, but we have all sorts of, let's say, projects that we are working on. We are working on image analytics, so we are trying, for example, to detect a big rock, you know, to have other type of angles. So we have cameras, we have drones. We have a bunch of use cases that we are working on, and not only prototyping, but actually in production, and we are constantly receiving feedback. We know what works and what doesn't work, so we are trying to improve. Yeah, and we have a deadline on this, 2025, so no pressure.
It's close. Okay, unfortunately, our time is up,
Okay,
but
cool.
at least you have two people you can...
Yeah, we have 2 t-shirts, good.
who are going to be very happy in wearing your designs. Thank you so much, Cristina
you.
Gurguta.